In this video, we will build a LLM router that will automatically choose model based on difficulty of the user's query. We will run this whole project on the local machine. We will be running models on local with Ollama. We know that large models are better at reasoning, but they are expensive and slow. Whereas small models are cheap and faster, but they have limited capacity to answer reasoning based questions. If we redirect all the queries to large models, it will be really high latency and also it will be costly. And if we redirect all the queries to smaller model, then some questions might be answer will be wrong. So instead of manually choosing models, we will today train a classifier to decide automatically which model it should route according to the complexity of the query. Before diving deep, let's understand what is a LLM router. LLM router is a decision model that takes input prompt, predict required capability, routes to the appropriate LLM. To train the router, we need custom dataset, which consists of simple as well as complex algebraic word problem. For simple query dataset, we will be using squad dataset. For algebraic word problem, we will be using Equarad dataset. We will be using Hugging Face dataset library to import the dataset, and we will be using pandas. For the simple queries, because we are using squad, we will be loading it. Then we will take the trained questions, which are 10,000. Only 10,000 questions we will take. And then we will split the query and see if it is in the length of less than 12, because we are taking a hypothesis that if the question is lesser than 12 words, it means that it is a simple question. And you can see an example of the simple question here. And then we will be loading the Equarad dataset for complex queries. We will be taking only questions from the trained dataset, and you can see an example of algebraic question. We will be taking 5,000 and 5,000 from each of the dataset, and for the simple query we have kept the label as 0, and for the complex query we have kept the label as 1. So it is like a binary classification. Before we go to the feature extraction step, let me show you which models we are going to use and their capability on complex questions. So for our non-reasoning model we are using Gemma, and for our reasoning model we will be using LFM thinking model. Let's see a classic question with our non-reasoning model. How many are there in strawberry? So it says basically the answer is 1, which is wrong. And let's now check the same question with our thinking model, which is reasoning based model. So it is thinking and taking some time for reasoning. It is seeing word by word of strawberry. It is also indexing them. So it says the right answer. R appears 3 times. Although it takes a long time, it thought for 35.9 seconds. Let's see another question. If 1 kg of sugar costs 50 rupees, how much 500 gram will cost? First we will give it to non-reasoning model, which is Gemma 1 billion. So it is calculating and it says 25,000 rupees, which is absolutely wrong. Let's give the same question to our thinking model, reasoning based model, and see what it answers. So it is thinking. It thought for 12 seconds and it answers 25, which is right. So we saw that the reasoning model is answering better than the non-reasoning model, but it is taking some more time than the simple model. Now let's see the feature extraction. For feature extraction, we will be using mini LLM model from sentence transformer to calculate the embedding of the question, which we will use as a feature. We will normalize the embedding and split the question and check how much length it is. Then we will be using a question embedding and question length as features, as well as we will take the label to create the dataset. And now we have converted it to a data frame. It contains the query embedding, question length, and the label. Train router, we have 2 options. Either we can train a simple ML model or train a small transformer classifier. For this tutorial, we will be training a gradient boosting model. Now let's see how to train the router. We will be reading the data set that we created, and then we will be importing train test split to split the data into train and test set. We will be importing gradient boosting classifier and accuracy score. Here we are taking the question embedding and making each dimension as a separate feature, and we concatenate this and we drop the question embedding which has all the dimension as 1 and label. So now in the X feature we have all the dimension as separate features as well as the question length. Now we are splitting the data and test size is 20%, and we have taken random state as 23. Now the data has been splitted. We will be training our gradient boosting classifier. After training and predicting, the gradient boosting classifier accuracy is 100%. We are saving this model so that we can use it later. Now let's see the demo. We will first give a simple query to it. Hi, how is it going? So you can see that latency was very low and it got routed to the small model. Now we will give a query which we asked earlier. If 1 kg of sugar costs 50 rupees, how much 500 gram will cost? It's taking some time, which is a good indication that it got routed to a larger model. Let's wait for the answer. So here is the answer. It says 25 rupees and it got to the reasoning model, to the Raj model. It had some high latency. If you liked this video, consider subscribing. I will see you in the next video.